So hi guys, my name is Steffi, and as I'm the coach, I have the honor to introduce you now to the presentation of the app C# developed for the ZEISS Software Campus. Who's behind all the magic? This incredible team. First of all, our charismatic project lead Flo, and also I would like you now to welcome our incredible team consisting of Carl, Nicholas, and Leo, Fuang, and also Jonas, who will start off now with the presentation. Enjoy.
Yeah, thank you, Steffi. To start off the presentation, I would first of all welcome you, and I want to introduce you to Carl. Carl is a fellow computer science student here in TUM, but he seems to be acting very strange. Do you notice anything? Well, it seems like he's holding his phone way too close to his face, so this might be a sign that he has a visual impairment. It would definitely make sense for Carl to visit an optician to check that, but unfortunately, he's so busy with being an excellent student that he doesn't want to make up the time. He's just too busy studying. So what if there was a way to help Carl, whether he has a visual impairment or not, by only letting him use his phone?
There actually is a way, Jonas, and the app is called C#. C# has to track user behavior related to eyesight using the sensors of the iPhone. Afterwards, it has to analyze the data with the help of a domain expert, that is an optician or ophthalmologist. To support the analysis of that domain expert, C# has to visualize the data on a dashboard in such a way that it's understandable for them, so by using graphs and curves instead of just displaying raw data. Furthermore, C# has to be designed in a modular way so that we're able to deliver several modules in the end. It's going to be 2 modules, a background and a foreground module, but more on that later. And C# has to fulfill all of those requirements while minimizing cost, which is in our case energy, because nobody wants to use an app that consumes too much energy. And before we now dive deeper into the more technical part of our presentation, I would like to talk about our project and what makes it so different compared to a lot of other projects this semester. The main reason for this is that we're still working in research context. That means that there's not a lot of research on using phone data to detect potential visual impairments. Therefore, our customers gave us a lot of freedom in how we want to approach this problem. What we then did after having a lot of brainstorming sessions was to look at behavior of people with visual impairments, like our friend Carl, and then try to map this onto sensors that are available on the iPhone. And to explain this to you in a slightly more technical way, let's give it back to Jonas.
Yeah, thank you. Thank you, Nico. First, I want to explain some of the tools that we use to tackle the problem. First, we're going to start off with the sensors. So among the sensors that we're going to use is the true depth camera. The true depth camera helps us to detect how far a user is folding their phone away, so if it's too close or too far. Then we have the ambient light sensor that is very useful to detect the user's vision in different lighting conditions, and also GPS data to give the data more context and depth. Unfortunately, Apple is very restrictive with giving apps sensor background access. That's why we had to implement a workaround. And as a workaround, we decided to introduce mock-apps. Mock-apps are apps that mirror functionality that is already known to the user, so for example, a weather app or a memes app, and thus allows us to access the sensors in the background while the app is used. Then we also can do vision tests, which helps us to further verify results, and also push notifications where we can interact with the user and get his input in certain situations. So when we collected all the data, it is crucial for the system that experts can have a look at the data and state their knowledge. And this knowledge is stated in the form of decision rules. Then the data gathering and analysis is the place where all the data is collected and then further processed and refined. And last but not least, the system gives a recommendation to the user, which tells him that he's likely to suffer from a visual impairment or not, and should thus visit an optician. So now let's have a quick look at all these different parts and how they play together. As I mentioned before, we have the mockups. So whenever the user starts to use one of our mockups, we then can activate our sensors in the background. When the sensors are activated, they retrieve data, for example, the facial distance, and send it to the data gathering and analysis module. When that is done, we can also gather more data through the push notifications and the active vision tests. When the data is collected, then one of our domain experts has a look at the accumulated data in the dashboard and can then formulate his decision rules, which influences our decision-making process. Once that is done, the calculation starts, and in the end, we send a recommendation to the C# app, which then notifies the user that his results are there and he should or shouldn't visit an optician. To explain the more slightly technical details, I hand it back to Nico.
And because we use a lot of hardware in our project, it is necessary to talk about what kind of hardware we use and what we use it for. First, we have the user iPhone that runs our C# app, which is responsible for the sensor tracking and also the active user participation. So the mock apps, that shouldn't happen, the push notifications, and also the active tests. And of course, also displaying the result in the end. Second, we have the test iPhone that runs our sensor test app, which is responsible for measuring the expected energy consumption of each of the sensors to be able to use that for our C# app. Both devices communicate over the internet with our web server that is together with a database responsible for the data gathering and analysis. Both the web server and the database run on our virtual machine. Last but not least, there is the Optician PC that runs our dashboard in the browser to be able to integrate expert knowledge into our analysis. And to show you how all of this works in practice, please have a look at Carl, who is using one of our mockups right now, precisely the Memes app. And right now, the sensors are activated in the background, which you can see by the green dot at the top of the screen. And C# is collecting data right now and also sending the data to our web server for our domain expert, Fong, to be able to analyze that data afterwards.
Yeah, it's my turn to analyze the C# user data today. Let's have a look at the distance to face chart first. Oh, this peak indicates that there are a lot of users who hold their phone really close to their face. This could indicate that they are short-sighted. There doesn't seem to be a rule for that yet, so let's add one right now. Based on my expert knowledge, around 20 centimeters should be a good threshold. For the visual impairment, we select myopia, which is the medical term for short-sightedness. And done. Now the system should assign a higher probability for myopia to users who hold their phone less than 20 centimeters away from their face.
And to see how Fong's analysis can help Carl improve his vision, please have a look at our trailer.
Let's have a look at our current status. We'll start with the app side. We now have access to the distance between the phone to the user's face. Next, we will implement active user participation and written data from more sensors. Another thing to do is sensor testing for cost estimation. In terms of the web server, we have implemented authentication, which supports registration and login for both the app user and the opticians. What's more, sending and receiving data are already working. The next thing to do is refining the API. For the dashboard, we have already implemented the data highlighting. Next, we will implement the adding decision rules, which describe the relationship between certain symptoms and visual impairment. In addition, displaying collected data is in process. Finally, the database has been set up in operation. That's everything from our side. Thank you for your attention. Especially, I want to say thank you to our customers, Alex, Jens, and Maximilian, for supporting us. Let's hand over to our customers for any question.
All right, so thank you very much, first of all, on behalf of myself and also of Max, who's sitting down there, and Alex, who's currently in Aalen. He will be watching your presentation later on as well. Great app you have developed so far, and also great dashboard you've developed in the background as well. It was great to see it in action as well. But you're also collecting a lot of rather sensitive data with your application so far. Have you already installed some mechanisms to prevent any issues regarding privacy, or can you even think of further processes that could be implemented maybe during this the coming 4 weeks, or maybe even in the future?
Yes. Yes. Yeah, that's a very good question. Well, of course, we'll deal with authentication so that only the users access their own data. And further, we could think of, for instance, pseudonymizing the data so that each user is only accessed using some pseudonymous hash or handle. And we could also increment the data on the server.
Okay, very well. Thank you so much, and enjoy the rest of the show.
Thank you.